Hey gang, Mocha Boy here. Thanks for dialing in. And yeah, today we're going to be covering a pretty big topic. This is a new flight controller on my bench. It's not new to the RC world. It's been out for about a year or so, but I haven't touched it until just recently. This is the Naze32 board, and this is a flight controller that's based on the STM32 platform, and it comes off of the bench of TimeCop, username TimeCop on the forums. Very talented developer and engineer. This board is a 32-bit variant, or supports rather a 32-bit variant of the multi-Wii platform. So you're getting a lot of updates with the package. You're getting a lot of capabilities with the package rather, and in a much smaller size. If you've seen some of my other videos, I mean, this is probably 1/5 the size of an APM module, but has almost all of the capabilities. What they were able to cram on a 36 millimeter square board is just insane. So the way that this is going to work is I'm going to walk you through a bunch of things. We have a lot to talk about. I'm going to cover a few safety considerations when you're working with this, because as much as this has been in production for a while, it's this is not the type of thing that I would recommend for a first-time flyer unless you were absolutely meticulous with following directions, or at least had some inkling of the hardware that you were working with. Once you go through the documentation, it's actually not that bad. As a matter of fact, I was able to get one of these installed in a quadcopter and have that quadcopter test hovering inside of 5 or 10 minutes. It was the only other boards that I've been able to do that with are CC3Ds and the Open Pilot project. So with just a couple of very basic things, we should be able to get the board set up and then inside a quadcopter and flying in short order. So anyway, what we're going to do is I'm going to give you a quick tour of the board, give you some considerations on where certain things are going to go, and what things to connect, and especially what things not to connect. I will show you what a working implementation of these boards look like in a quadcopter, and then we're also going to take a look at the new base flight configurator. At the time of this recording, there are a number of different GUIs that support configuring these boards, but they've taken it to the next level, and they've made they've pushed all of those applications into the cloud via a Chrome application called Base Flight Configurator, and that's the primary way that we're going to be working with this. As far as the depth of the content, there's so much to talk about here, and I'll probably end up breaking it out into separate episodes. So this is going to be the bare minimum that it's going to take for you to install one of these, configure it, and then get flying. But there is one very special modification, or one very special component that I do want to cover, but I want to cover it in detail, and that's the KBOSD MinimOSD board. Because this board does support telemetry as well as video overlays and a couple of different types of telemetry. But I'm going to be doing that in a separate video, only because that subject alone requires quite a bit of thought and walking through. So we'll cover that. Anyway, so let's get started with the overview. This is. So the arrow right here, that's your front-facing arrow, but with just a couple of command line changes, you could, for instance, if you had a custom build, orient this in 45-degree fashion, even turn it this way, and then you would denote this offset in the command line interpreter, and I think it's like a yaw offset. This would be like a 270-degree offset. This would be this would be a 180-degree offset, that kind of thing. Now, as far as hardware on the board, on the left I have the regular Acro Naze. This is the Naze without the barometer or accelerometer. And then over on the right-hand side, this is a full-on Funfly Naze with all the bells and whistles. It has the the MS, that's Measurement Specialties, MS5611 digital barometric pressure sensor. These are actually not available in the United States, at least not easily. You'd end up having to buy a breakout board, remove it, and then add it on. But I have been able to source these on AliExpress. The prices have been fluctuating. You'll see them from anywhere from $7 per chip to on up to $18 per chip from some of the sellers that I see on eBay. And again, this is the digital version. This has, there was another version before this that had a plastic case. This has a stainless steel case. The component to the left, or to the top of that anyway, is the Honeywell magnetometer. So this is what gets you your north-south orientation. This component right here is the accelerometer, so that's the InventSense MPU. I believe it's a 6050 or 6000, yeah, probably the 6050. And on the Rev 5 boards, one of the newest additions is this 16 megabytes of SPI flash. So that's probably just to support some onboard data logging. This component right here, this is the CP2102, the Scilabs chip, the USB to serial bridge. So when you do plug this in for the first time, you will be prompted to install a driver, but all you have to do is do a search for CP2102. You would have seen, I have a video on a CP2102 breakout board, but this is an on-chip serial converter. So USB into there, and then serial connection into the STM32. So that's the STM32 right there. And then, so as far as pin assignments, what's really interesting about this board is the way that the pins were able to be broken out. I've never seen a more compact solution for pins, especially when you consider that the input pins are, 8 input or potentially even output pins, because these are all configurable, with some not so difficult hacking. But the ones that are important, at least for what we're going to be doing today, is so on the top of the board, pin 1 starts at the top, and then so it's pin 1, 2, 3, 4, 5, and then let me just check my documentation here. And then on the back side, it's going to be, oh, it's actually numbered. Never mind, 4, 5, 6, 7, 8. Okay, so now the reason this is important, first pin is ground, next pin is your VCC, and then the third pin is your PPM input stream. Now the way that I have this set up is on a micro, so I'm not using PWM. I like to keep my builds as clean as possible and with as few wires, so I try to run with a one-wire interface. Now that being said, you can configure this to work in additional modes that will remap these pins based on what you're trying to do. So let me give you, let me just bring out a little thing here, hang on. Right, so this is a page that I printed out right out of the user manual that's available on AbuseMark, and this is what I'm talking about. Depending on what mode you're running the board in, both the receiver pins as well as the servo output pins, the ESC output pins, will be remapped. And as you can see, if you're running in standard mode, you'll have the top pin being mode 1, 2, 3, 4. But if you're running in say servo mode, where you want to run with a gimbal stabilized platform, because this flight controller does support gimbal stabilization, and that remaps these first 2 pins to servo 1, servo 2, and then the other map pins. Now, as far as the receiver is concerned, the receiver port, again, this is completely configurable, but you have ground, power, and then 1, 2, 3, 4, 5. As far as the pins are concerned, let's see. The ones that are of interest to us, again, is going to be ground, power, PPM input, and then pin 3, as well as pin 4. These are going to be the GPS pins. Now, we're not going to be doing a GPS setup in this video, only because it's fairly involved, and it requires some additional software that's been forked off. We're going to be covering baseflight in this, but that one's Harakiri. We'll cover that in a separate video. But yeah, those were the pins of interest that I wanted to point out. As far as the output pins, again, Timecop follows a standard placement convention where more often than not you'll see the ground pins to the outside of the board, so that's just a key there. So you have signal, power, and ground. And then in this orientation, pin 1 is, just double check. Yeah, pin 1 is actually down here. It's not up here. So it goes 1, 2, 3, 4, 5, 6. And I'll show you what a couple of examples of what those pinouts look like. When you get your board, you will be sent a number of different headers. So one of the very first things you're going to do, and call this kind of like a price for entry, is you're going to have to solder on your own connectors. You can use all of them, or you can use just some of them. In the case of the motor output pins, I only soldered in the ones that I needed. And just a quick tip there: these will go in, and then you can just use a little bit of polyamide tape or Kapton tape to secure it. And then when you go in, tack a corner, reposition, and then tack the opposite corner. And then when you're happy with the angle that they're at, because this will come askew, when you're happy with the angle is at, then you can start going in and soldering in all the other pins. Flux is very handy for this. Just brush it onto the pads and it'll just sip the solder right off of your soldering iron. And then the same thing goes for the input-output pin, or the receiver port pins. This is the way they go in. And then I would not pre-tin these pads. I would drop this in, tape it down, and then again tack pin 1, and then tack the opposing pin on the other side. And then when you're happy that it's not completely askew, then go in and start tacking in all of the other ones. But when you have 2 pins tacked, you can still just barely move this around so long as they're not too thick. So that's going to be your first. That's going to be your first challenge. And then if you have let me see. Okay, there are additional pins that if you have 2-row header pins, the ones that are going to be very interesting, and I would absolutely encourage you to solder in, are the telemetry pins right here. Or they're not telemetry rather, but this is the serial port. So if you have, say, like a Bluetooth or even a 3DR radio, which I was able to get working with this, those will plug right into there. And then you can tap 5 volts off of the ESC power rails. So power, like the way that I have mine set up is I do signal wires only, no ground from the ESCs, and then I tap these 5 volt lines out to whatever serial device I'm using, whether it's Bluetooth or 3DR. And just an interesting note there, if you are running with KBOSD, you're not going to need even any of those. Like, it is handy to have the wireless serial devices, but with KBOSD, you'll be able to do all of your PID tuning and be able to access all of the menus that matter, at least for flight, directly from your transmitter sticks. But again, I'll cover that in another video. So, going back to this board, along the edge here, so that this top set of pins is a battery sensor, so a voltage sensor. This will take anything up to, I believe, 6S, and all this does is this is just a set of voltage dividers that'll step the voltage down and feed it into an analog to digital converter, and then out comes your voltage. The second port is a buzzer. And this is polarized, so I can't see what it's probably negative to the outside, positive on the inside. So if you have like, this board will also do a low voltage alarm if you have an off-board buzzer. Now, one consideration there, if you do that, just remember the buzzer is magnetic, so don't keep, especially if you're running the full board, don't keep that buzzer anywhere near this board, because that will upset the magnetometer, since it creates a magnetic field. Last pin on here is the telemetry pin, so if you're running with FreeSky telemetry, this will, I'm not in this case, but there are a lot of people that do, then you'll be able to push that telemetry stream out to your FreeSky radio. Now on the back, a couple more pins on this board that matter. The boot pins, so if you ever need to put this in bootloader mode, you would have to short those 2 pins and then power it up, and then the blue light's on solid, and then you're in bootloader mode and you'll be able to push firmware to the board. You would only ever have to do that in very specific cases. It's all covered pretty well in the documentation. I just wanted to point those out. This pad right here is a 5 volt output. So if you need to either tap or feed 5 volt devices, you can feed or tap from that pad, or you can do it from any of the ESC any of the motor output rails. Be careful not to confuse these two or short these, because you will instantly fry the board if you short that pad to that pad. And right here, these 2 tiny little pins, these are 3 volt outputs, so if you're running any type of 3 volt devices, you can tap power from these voltage divided power output rails, and this is 3.3 volts at, I believe, about 100 milliamps, so just be careful with this, and they're marked which one's positive and negative. Now on the back side, you have your serial wired debug port. This is a standard 10-pin Cortex connector. Pin 1 is marked by the arrow right here, and it goes pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, on and on. Now, if you are going to be using an SWD interface, say from like an F4 Discovery to push firmware to the board, you're going to need pins 3 for ground, pin 2 for SWIO, and then pin 6 for SWCLK. Those 3 pins will allow you to push firmware to this board using something like ST-Link with an F4 Discovery board. I just thought I'd throw that in. Now, as far as these pads are concerned, this is where we start to run into some of the issues with 5-volt pads versus 3.3-volt pads. The first pad is a general purpose input-output pin for any type of inputs that you want to, any other additional sensors, say sonar. This pad on the left is 5-volt tolerant. This pad on the right is not. So 5-volt, 3-volt. And then this is another ADC, another analog to digital converter, and this is also only tolerant up to 3 volts. So be very careful if you're working with these pins. There's 2 additional pads here for the I2C interface. Again, these are 3.3 volt tolerance, so again, be very careful when you're working with those pads. So yeah, that covers the board. Again, it's an amazing piece of technology when you consider how much was able to get packed into a 36mm board. I mean, I've flown pretty much all of the open source controllers. I'm not too crazy about the proprietary ones like Naze, so I can't say anything about those. But for what they were able to pack into these, just amazing. And it'll be very interesting to see where some of these projects go as they cram even more components onto here. For instance, with the Revo board, it's a lot of the same hardware, but then on the back, you've got a Hope RF 23B chip. I think it's a 100 milliwatt transceiver, so that you have your radio transmitter and your flight controller all in one board. As a matter of fact, at the time of this recording, I know that there are developers working on daughter boards for the Naze32s that will allow you to run OpenLRS as kind of like a piggyback module to this, which is really, really cool. So, okay, that covers the hardware overview, and what we're going to do is, let me just point out a few things in the wiki to you that, well, not the wiki rather, but the documentation that are going to matter for as we start to move through this. For this example, we're going to be doing a quad X, not a quad plus. So what is my little? Okay, so we're going to be doing a quad X, and orientation forward. Motor 1 is in the back, then motor 2 is front right, motor 3, motor 4. Top left is clockwise, bottom right is clockwise, and then the other 2 counter rotate. So that's a little different than some of the other flight controllers, but that's important to mention. One other thing I would like to mention as we go through this, and this is just a safety note, take the propellers off. Seriously, take the propellers off. The boards, when they come flashed, come with a feature called Enable Motors Stop, and I'll cover that when we go through the GUI. Essentially what happens is if you decide you want to skip a lot of what I'm showing you and go straight to arming the board, the motors will spin up as soon as they're armed. I'm not sure if that's a feature or why that's there, but you have to shut that off before you do anything else. At least from a safety perspective. I know that visually it's great. That the motors are spinning, but personally I shut that feature off, and I'm happier for it. Okay, so just for the purposes of illustrating what I want to do here, we're only going to be connecting 3 things to this. We're going to connect the receiver port. So again, I'm running in CPPM mode, and that's going to be, so ground, power, and then CPPM. That's that connector right there. And then for the motors, I'm going to run, let's see, this one is ground to the outside, signal on top. So this is my 5-volt line coming in from the ESCs, and then these are my other 3 motors that I just threw in a 3-pin header. Makes it a little bit easier to run everything, and look how neat that wiring is. So that's pretty much all you need to get this connected. But then I'm also going to connect in USB to this so that we have a serial connection to the board, and we'll actually go through and configure this. So that's what we look like so far. All right. this next part of the video, what we're going to do is we're going to get the configurator loaded, we're going to connect into the board, we're going to do some very basic calibrations, and then test for a motor spin-up. So first things first, as far as what to get and where to get it, if you just do a Google search for base flight configurator, that'll just pop on up, and you'll find that in the Chrome Web Store. Just go ahead and install that. I already have that installed, so I'm just going to go ahead and launch that. Right, so let's go through some of the tabs here. We'll start off an initial setup and do some of the calibrations. I'll walk you through a couple of the some considerations for PID tuning. But where we're going to be spending a lot of our time is in the receiver section, as well as the command line section. And I'll also show you a couple of tricks for the motor servo outputs. Just testing things like if your ESCs are calibrated. And one other thing that I do want to show you is how to calibrate all 4 of the ESCs at the same time. This is one of the things that's critical for getting the setup right the very first time, because if you get this part wrong, bad things happen. So you've got the CP2102 driver installed, the Silage driver installed, and you've got base flight configurator loaded up. So the first thing I'm going to do is go ahead and plug in. Now the way the board, or excuse me, the way base flight comes standard anyway, is that it's set to auto connect. So as soon as you connect and it detects the device, you'll just automatically be able to go in. And there is one thing I want to point out, and that is the baud rate for this. This is important because if you plan on using another serial device, say like a 3DR radio or a Bluetooth, both of those will require changes to the baud rate depending on how those particular devices are set up. So for instance, a 3DR radio is it comes out of the board, or comes out of the factory at 57,600. Now, if you do change the baud rate, obviously you can only connect with that 3DR radio, and for you to be able to connect in back over USB, you would have to change this back. I mean, obviously this is tied to the COM ports, and you'll have different COM ports based on the devices that you're plugging in, but I thought I'd just point that out. There is one other thing that if you're planning on using another serial device, is in the command line interpreter. There's another setting there that you have to set to match the baud rate of the device that you have. And if you don't know how to set the baud rate of your Bluetooth device, just Google it. There's tons of videos on how to do that. I like to use a 3DR radio only because it gives me a wireless connection to the quad as I'm doing tuning. And if you have the option of doing that, or even working with KBOSD to do all of your PID tuning. So anyway, sorry for the aside. As far as the first tab is concerned, one of the very first things that we're going to do is calibrate the accelerometer. So you just click that button and then make sure that the board is level, and then it'll grab its calibration offsets, and then you're off to the races. Now with the magnetometer, you need to do the magnetometer dance, and if any of you have ever watched the APM setup videos, it looks something like this. You have 30 seconds to move it through all orientations in a 360-degree axis. So 1, 2, 3, 4, then turn it on its back. 1, 2, 3, 4, then turn it on its nose. 1, 2, 3, 4, and then do that all in 30 seconds, and then you should be all set. And that'll grab your magnetometer settings, and it will know what true north is. And once you're done there, some of the other so for declination. If you look up, there are declination charts, and this only matters if you're running in GPS mode. Depending on where you are in the world, you may have a declination offset, and this is something you can look at somewhere online. Let me see if there's a declination offset. And basically what this is you can get your magnetic declination based on your location. You just drop your you drop your location right into there, and then it'll give you the number to drop into there, and that's just for fine-tuning true north on the board. As far as the battery is concerned, if you're running with the battery sensor, then this is where you can set your alerts. So if it hits 3.3 volts per cell, it'll go off. And as far as the throttle settings, this is something that we will cover. If you're using an Acro ESC, the default steps for that electronic speed controller is 800 steps of resolution. Now that said, If you're using something like a Futaba I think has something on the order of 2048 steps of resolution, but you can't use all 2000 of those steps. You're stuck to somewhere between 1000 and 2000. This is one of those things that we're still trying to tweak, but the safe numbers that we found are these ranges. The defaults are actually pretty good, but what this means is you are going to have to play with the endpoints on your radio to match these settings, and I'll show you what that means when we go through the receiver setup. And as far as trims are concerned, we're not going to be doing that because, I mean, I've run this without accelerometer trims and it's worked just fine, because if you do the calibration, then you should be all good. Let's take a quick tour of the CLI. Now, if you ever need to know what all of the commands are, all you have to do is type in help and it'll give you a list of all of the features. Now, we're not going to use all of these, but I will show you the important ones. A couple of considerations that you have to make here is if you make a change, you have to hit save before it actually saves. It's the second you set something, it's immediately available on the flight controller, but it's not saved to EEPROM until you hit save, so just remember that. Now, as far as the mixer is concerned, one of the things that I really like about this flight controller is that the mixes are completely configurable. So you can run all kinds of weird and exotic combinations, and all you have to do is just set the C mix to match the motor outputs that you're running. Now, as far as features, this is where we're going to spend a little bit of our time, and what we can do is just say feature list, and this will give you all of the features that we can either enable or disable. So the way that you enable a feature is you take one of these parameters and you just type in feature, say ppm, and it's enabled. Now, if you need to disable it, you would say feature minus ppm, and now it's disabled. So we're going to feature ppm because we're running in one-wire mode, so that's on. We want to run the battery monitor, so we'll turn that on. Now, you heard me allude to this earlier. Motor stop, this is a really important step. If you were to arm this board without running this next configuration, the motors would spin up immediately, and if you have propellers on them, boy, you're done. So one of the other features we're going to enable is feature motor stop. And that'll make sure that when the board arms, everything will, the motors won't spin up, and they'll only spin up once you hit the minimum throttle width. So let's see where we're at here. Now, as far as the other settings are concerned, servo tilt, that you would use that, you would enable that if you were running in gimbal stabilized mode, and I think with tricopters, but I'm not sure. I haven't set those up. Gyro smoothing, or if you're running with a rig that's extremely vibration prone, what you can do is you can smooth the signal that's coming into there using a low-pass filter algorithm, and that's probably what it is. Now, if you're running with a lot of the boards that have these floating vibration-isolated plates, then you should be fine. But that's just something I thought I'd point out. GPS, obviously you know what GPS is. Failsafe. So interesting thing here. Failsafe, I typically run it from a receiver, but this does support sending out a failsafe stream directly from the controller. So you can set failsafe. You can set a failsafe mode that executes from the controller, or you can do it from the receiver. It's up to you. I choose to do the receivers. So obviously sonar if you're running it, telemetry if you're running that. Power meter, I don't know what that is. Vario is for, I believe, your barometric pressure sensor. So you would need to install that if you were running the, or you would need to enable that rather if you were running the full board. I have to look up a few of these other settings, but that'll be what you'll need to get the board up and running. We're going to be doing the bare minimum for now. So just to review those again, it's going to be PPM, enable PPM, enable VBAT, and enable motor stop, and then you should be all set. Okay, so when you're all set with that, all you have to do is just hit save, and it'll reboot the controller. This takes about 15 seconds, and then we can move on. So I'm clicking on the initial setup tab. We're going to start back there again. So you have a choice here. You can start off with the initial setup and do your calibrate accelerometer and magnetometer settings first. Maybe do the CLI settings first, just to make sure that the receiver can connect, and then run through the calibrations. So what I mentioned earlier about having to spend some time with the receiver, now this is the next thing that we have to do, and this will take a little bit of time to get set up. But for this, we're going to need to actually plug in the rig. So we're plugged in over USB, and I'm plugging in the battery for the rig. And just waiting for a bind. Okay. Now I'm running on a Futaba, and let me just point out a few things that I have configured on the Futaba. Flight modes I have set up on my 3-position switch. And then my arm switch is this 2-position switch over on the left-hand side. And I'll show you what that means. I'm going to assume that you know how to set up your radio so that it sends out, you know, how to configure your switches against your channels. So we're not going to cover that. I just needed to point those things out because for this part, what we need to do is we're going to set up your throttle ranges, and then we're going to set up an arming switch. If you don't set up an arming switch, the typical conventions apply, and that's, you know, push off to the right, yaw right to arm, yaw left to disarm. And this is all covered in the documentation, what the stick movements are to do things like accelerate your calibrate your accelerometer or calibrate your magnetometer. You know, there are different stick positions for those things. Now in this case, I like to run with a switch. It's just easier for me to see and easier for me to work with. As far as this page is concerned, a couple of the important things I wanted to point out is that if you're running with an underpowered rig, you can probably set your throttle midpoint just a little bit higher so that it reaches that you know, 50% hover range a little bit faster. As far as RC rate's concerned, I haven't had a chance to play with this, but my understanding is that if you want to get the quad to respond faster to stick movements, so, you know, if you wanted to, say, spin at some like completely psychotic rate, you would raise RC rate. I don't know what the top end for this is, so, you know, I'll leave that to you guys to tell me. And then RC Expo is exactly what it says. It's just, you know, it introduces a dead band or a dull band kind of in the center of the sticks, so that if it's too twitchy, you can tone it down. So, you know, I'd imagine that for some of the sport flyers and free flyers out there, you'll be running with high rates and very little expo. But if you're starting out, just leave it where it is. It's fine for now, and then you can raise these numbers as you become more familiar with the system. All right, so as far as calibrating your stick ranges with your transmitter, this is going to differ from transmitter to transmitter. I was able to run this off of the defaults without making any changes, so I'm going to stop short of saying, you know, go through here and start mucking around with numbers until things work. But what I will do is lay down just a couple of ground rules. Again, I'm running off the Acro ESC defaults as kind of a baseline, and then you can change them from there. You know, obviously TimeCop thought it was a good idea to put those stick resolutions at about 800 steps, so that's what I'm gonna stick with. There are settings within the CLI that if you have wrong will prevent you from arming the board based on what the minimum and maximum checks are. Okay, so I only really made one change to this, and you know, I will leave this up to each flyer to decide whether or not they want to do this on their own. But the only endpoint that really mattered to me for getting this right, because if you get this part wrong, the board won't arm, is the throttle. So in order for me to get a range of 1,000 to 2,000 PWM, I had to set my stick ranges to 125% on both the low side as well as the high side. So this is what it's at low, and that's at 1,006, and then on high it's at about 1,950. And you know, that's my range. That gives me a nice little buffer outside of the min and max checks, and you know, that's what allows me to arm this board. So those are my numbers. Now what happens is, like, just watch the PWM numbers, the pulse widths, as I change these percentages. So you'll be doing this on, you know, if you have a Turner G9X, you'll be doing the mix weights, you know, and essentially what you want to do is you want to get as close to about 1,000, and then 1,000 on the low side and 2,000 on the high side. Some people say 1050 to 1950. These are the numbers that work for me, so this is what I'm going to stick with just to keep things simple. And then as far as the other sticks are concerned, now remember what I said about enable motor stop. So, you know, this is my arm switch, and you know, I got the green light. You can't see it on the board, but I got my green light on the board, and the motors didn't spin up. That's a very good thing. So, but if I start to, One of the things that I did do with my radio is that you know, I got it so that right around 1050 is when when the motors kick in, and that's worked out pretty well for me. So I've got a nice range. I go from about 1050 to 1950. That's a little bit more than 800, but you know, I haven't had any issues with my sticks. One of the other things that we're going to do is we're going to take a look at the auxiliary configuration. Now this is where you set up your flight modes, and the three that I tend to work with are ARM, Horizon, and angle. So angle is pretty much deprecated. Essentially what angle is attitude mode. It'll just automatically level itself if you let go of the sticks. Horizon is what a lot of the free flyers use, and Horizon allows you to go past that 45-degree bank angle maximum, and you know, allow you to do things like forward flips, side flips, whatever, you know, barrel rolls. But if you let go of the sticks, it'll still come back to level. If you run with none of these things armed, the board is automatically in rate mode. So that's just one other thing to keep in mind. And then as far as barrow, I believe this is altitude hold. I have to look up what these other ones are. And one of the options that I don't see on here are any of the GPS hold options. But again, you know, we'll save that for another video. For our purposes, the flight modes that we'll be using are ARM, Angle, and Horizon. And you know, essentially the way this works is if you have a 3-position switch, you'll get low, medium, and high. If you have a 2-position switch, you'll have low and high. And then to enable the features, all you have to do is just put a checkbox in the pulse width range that you're looking for. So for instance, with Angle, I'm going to say, okay, so my C switch is bound to auxiliary channel 1. So I want to say in the top mode, that's just automatically rate mode. But in the medium pulse width, I'll do Angle, and in the high pulse width, I'll do Horizon. And then you know, as you flip through those 3 different flight modes, that's how it works. Now, as far as you know, you can do 6 flight modes on here if you wanted to, but you know, I'll leave that for you to figure out how to even send those pulse widths or those stick combinations. For right now, really all we care about is Angle and Horizon. And then once you're done, go ahead and hit save, and then that'll bind those. Now, as far as attitude control is concerned, if you are running in Angle or Horizon mode, if I arm the board and then I hit ARM, excuse me, not ARM, if I hit Angle or Horizon, that red light comes on. So that's your status indicator. So your ARM switch, you get a solid green light, and then flight mode for Angle is a red light, as well as Horizon. So just thought I'd point that out. Okay, so moving right along, let's see, GPS. Obviously, if you're running with GPS, you'll be able to get your GPS telemetry data here. We're not going to be doing that in this, we'll do it in another video, but okay, this model doesn't support servos because we're not running in that servo mode. Now with the motor servo output, what you can do is from here, you know, let's say you're setting up your board and you're not sure if you wired in your motors right. All you would have to do is turn motor test mode on and then start moving the pulse width slider up until your motor starts to kick in. Obviously, if you're doing this, take the propellers off, but you know, this is a good way to verify spin direction and ESC calibration. So for instance, if your ESCs are not calibrated and you know, at about, so for this one, 1072 is when this motor kicks in. So for motor 2, it should kick in right around 1070. Okay, it actually kicked in a little bit earlier. 1064, motor 3, 1072, that one's good. Motor 4, 1064. So a couple of these are actually off by about 10 nanoseconds. So, you know, this is probably a good candidate to go ahead and calibrate the motors, and this is one of the things that I did want to show you. But again, this is a very handy tool for being able to diagnose motor ESC calibration issues as well as motor spin direction. So, you know, you don't have to worry about hooking these into an Arduino. You have that test mode here. So, turn that off. Now, you heard me mention before that there is a technique here for calibrating all 4 of your ESCs, and it's a very simple technique. It just requires a couple of commands and powering the system up and down to get them. Now, the way ESC Calibration works is just by default, and it's built into a lot of different firmwares. As soon as you send anything above, I believe it's 1850 pulse width, that automatically puts it in calibration mode, and that's a lot of the ESCs. So the idea here is, how do I send a high stick mode command to all of the ESCs all at the same time? You can't do that from a radio controller unless you have, like a pigtail that splits your signal off into 4 different signals. But in this particular case, with just a couple of CLI commands, I can use the motor output ports to send a minimum throttle command to all 4 ESCs. And the way that you do that is this. There are a couple of nuances with the way the baseflight configurator does the reboots. You have to get out of the tab and come back into it, but you'll see what I'm talking about in just a sec. So we'll go into CLI, we'll type in set just to get the initial command, and in my case it's going to be, min command is going to be 1050, and I have that matched to my min throttle, as well as the min check. Notice the board is not plugged into the battery yet, so I'm going to type in min command, set min command equal to 1980, hit enter, and then hit save. That'll reboot the board, wait for the lights to go through to finish the bootload sequence. And once you're there, you have a red and a blue light, go ahead and power up the board. Now listen to the tones. Okay, that's calibration mode. So one of those nuances, the board is rebooted. I'm going to hit initial setup, and then I'm going to come back into the CLI as soon as this responds. So back into the CLI, and now again, set min command equal to 1050, and listen to the tones. Oh, excuse me, and then I hit save. And then as soon as you hit save and it reboots, all of the motors have been calibrated and you're set. Now, one last final check that we're going to do is we're going to go back to that motor servo outputs. We're going to go into test mode, and let's just check to see what they all kicked in at. So 1064, 1064, 1064, let's see, yep, 64. So we're in good shape. Everything's calibrated and they're all spinning up at the same time, which is perfect. Get out of there, and all your ESCs are calibrated. Okay, so for this last part, this is just going to be a little bit of commentary on what some of the set min commands are, or what some of the set commands are. This is just for background knowledge, but let's take a look at the entire list of available things, make sure we got everything. Mixer. Oh, okay, you know what, before we do that, so map. If you type in map, this is the current configuration of your mixes, and what this says is channel 1 is aileron, channel 2 is elevator, throttle, rudder, and then auxiliary channel 1, 2, 3, and 4. Now, if you're running in mode 1, or if you're running in the default mode for Telemetry 9X, which is like RETA, R-E-T-A, the way that you do this is as simple as typing in just the new order. So map RETA 1, 2, 3, 4. And everything's automatically switched. And that's how you change the motor inputs to match whatever it is your radio is doing. So in this case, I'm going to do map AETR 1, 2, 3, 4. And it says 1, 2, 3, 4. Just remember that's auxiliary channel 1, auxiliary channel 2, 3, and 4. You can flip those around to match your stick positions any way that you need to. But these all correspond with channels. So channel 1, channel 2, channel 3, all the way on up to channel 8. So that's how you map those. Let's see, we covered features. Okay, and let's look at set. So there's some important numbers here that we'll have to take a look at. Mid-RC, this is a number that stymies a lot of people. For Futaba users, this typically should be about 1520. And for whatever reason, in my case, it works at 1500. For all of the other radios, it'll be 1500, but for Futaba, it's supposed to be 1520. My min throttle and max throttle, that's exactly 800 steps of resolution. I'm going to leave it at that and just work my radio around those settings. Now, min command, min check, and max check, I want to say that I understand what these do, but I can't. I'm hoping that one of you guys can chime in on what those specific numbers command. Now, in my case, min command was 1100 originally, And when I did my ESC calibrations, when I plugged the motors back in, everything spun up. So I dropped this number down to match min check as well as min throttle. My understanding is that the minimum command that the board will throw out is 1050, and that's my read on what min command is. Min check, on the other hand, is the board won't arm unless the lowest stick position from your radio outputs something less than 1050. That's my read on that. If I'm wrong, I'm sure somebody will chime in real fast. Now, as far as deadband and some of these other numbers are concerned, when you're running in something like an altitude hold mode, what the system does, what Naze does, as well as a lot of different firmwares, is introduce something called the deadband. And that what it does is it dulls the stick around a certain range. And in this particular case, it says the bottom end of the deadband is going to be 1400 PWM, and then the top portion of that is going to be 1500. That means if you're in something like a position or an altitude hold mode, you have to move your throttle outside of those bands for it to either move up or down. So that's essentially what those mean. The other thing I wanted to point out here was serial baud rate. Now, this is another important one if you're working with something like a 3DR radio or a Bluetooth module. You have to be very careful with this number, because if you get this wrong, if you forget about this number, you won't be able to connect in via USB. For something like an RC timer Bluetooth module, out of the factory it comes in at 9600 baud, so you would have to change this to 9600 baud for this to connect to that. And then for a 3DR radio, that's 57,600, and you'd have to set that. As far as the GPS types and baud rates, I still have a little bit of research to do there, because I do plan on running GPS on one of my other rigs. These boards are so affordable that they're probably going to end up replacing a lot of the boards that I have in my current fleet. And STM32 is the way of the future. Woohoo! Yeah, as far as PID tuning is concerned, this is a big subject. I'll cover it in another video, and we've already talked about a lot. I'm going to assume that you guys know how to use this. If you don't, go to the Multi-Wii wiki and look up these numbers. Roll, pitch, and yaw are what you're going to be using in your rate modes. For my micro, I chop all of these numbers, all of the proportional numbers, in half, and that's done pretty well for me. And that's roll, pitch, and yaw. Now, as far as altitude is concerned, this is probably for altitude hold mode, position hold mode, navigation mode. These are all the corrective forces that are applied. PIDs are a very interesting concept, and 15 different people explain it 15 different ways. I'm not going to add to the confusion. Look up the information and tune your boards. But these numbers are a little high for a micro. I'll share some additional numbers that I'm using for a small board, and then you should be done. So that's it. I know we covered a lot. This is a very complex board. It's not for a first-time flyer, or somebody who doesn't like to follow instructions and just likes to do things like attach propellers when they're not supposed to. To a board, to a quad on the bench. But look these boards up. At the time of this recording, these are available from abusesmark.com. That's directly from Timecop's hands in Japan, and it's usually about a week to your door. Or you can buy them at the multirotorsuperstore.com. That's the shop out on the West Coast, run by an RC Group's member called Postal. So quick heads up to him. He's been feeding us all kinds of crack. He's been feeding all of us addicts all kinds of crack, especially now that we're on to micros. And if you guys want to follow along with what we're doing, come visit us on the web. The flight team and I, we hang out on fpvlab.com, and specifically on a thread called Checking In from the Northeast. If you want to see what projects we're working on, this is where we're at. We got our own jerseys because we're big nerds like that. But one of the things that we're doing, big shout out to the team. Talk about a bunch of addicts feeding other addicts, because we all are running with 3D printers and have all made our own boards and made our own quads and all kinds of fun stuff. So big shout out to the NEFPV guys. Got a lot of fun stuff coming your way soon. So thanks for watching, and catch you on the next video.